Scientific notation is something that you should have seen last year. We're just going to quickly review it here. We're going to talk about going from scientific notation to standard form first. Standard form is just a normal form of a number. So the reason we have scientific notation, it's really just to represent really big or really small numbers. It's actually just a multiplication problem. You take a base number and we multiply it by some power of 10. So it's really simply just a multiplication problem. Our first step is to locate the decimal point. When it's just a number and it doesn't seem like there is a decimal point, it's always at the end of that number. So that's we could really write that as 2.0. If the exponent is a positive number, so if this number is positive, we're talking about a really big number and we're going to move the decimal place to the right. So that's what we're going to see here. Let me just delete that. That's what we're going to see here. We're moving the decimal place to the right to make this into a really big number. That's 2 billion. Right, if the exponent was a negative number, then we would move the decimal place to the left and we'd be talking about a really small number. All right, so let's go through some examples. These are scientific notation going to standard form. We're trying to turn that into a normal number. So we're first finding the decimal place. We're trying to move this 5 to the left. We're trying to make this into a really small number, so we need to add some zeros. We're going to just rewrite this number with some zeros in front, really just so we can move that decimal place. We're going to move it 5 to the left. 1, 2, 3, 4, 5. So this number is really 0.0000501. It has 4 zeros. It's never going to be a negative number. It always just turns into a small number, just like when we had problems like 2 to the negative second. That turned into the decimal 0.25. It's just a small number. It's not a negative number. So we saw that we needed to replace any empty spaces with a 0. Anytime you need to move the decimal place to a place where there are no numbers, you need to move that over zeros. All right, on the second example, we have a positive exponent. That means we're moving to the right. This is going to turn into a really big number. So we're going to add some zeros. We need to add 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The reason I said we needed 9 of them, I knew we needed to jump over these 2 decimal places and 9 more because our exponent was 11. So that means it needs to include 9 zeros. So we have 4, 2, 5, followed by 3, 4, 5, 6, 7, 8, 9 zeros. All right, this next one has an exponent of 0. That means we're moving 0 places. It is just that number. The decimal place doesn't move. The reason that is 10 to the 0, really anything to the 0, just equals 1. So this is really the multiplication problem, 9.2 times 1, which is just 9.2. All right, you should be able to complete these on your own. If you need help, please ask for help. All right, on the back, we're talking about going from standard form into scientific notation. So we're just going to break down what scientific notation really means just in this form so that we know how to get to it. The first number is always a number that's bigger than 1 but less than 10. It's a number in between 1 and 10. So we're going to have a decimal place sometimes, sometimes it's not. This could just be the number 5.0, which could just be represented as 5. It's always a multiplication problem between that number between 1 and 10 and a power of 10. And the exponent can be positive or negative depending on whether we have a really big or a really small number. So in this example, we have a really big number that is 65 million. We want to locate the decimal place and move it to a place so that now the number is between 1 and 10. So instead of being at the end, it has to jump in between the first 2 numbers. It's always going to be right after the first digit. So it's right after that 6. This is going to be the number 6.5 times 10 to some exponent. So we got our number between 1 and 10. we want to write this number down, followed by that multiplication part of the problem, times 10. Now we count out how many decimal places it moved. We can see that it was 7, 3, 4, 5, 6, 7. It's a really big number. So we know it's going to have a positive exponent. That's going to be a positive exponent of 7. The number of decimal places that the decimal point jumps is your exponent. If we have a really large number, we know it's going to be a positive exponent. If we have a really small number, we know we have a negative exponent. Alright, so in these examples, we see that we have a bigger number. We know we're going to have a positive exponent. The number that we want to get is 4.3. We want that decimal point to be in between the 4 and the 3 because that's a number between 1 and 10. So it's going to be 4.3, and it started out at the end of the number. It moved 1, 2, 3 spots. So that's going to be our exponent. Our exponent is positive 3 because we're looking at a bigger number, and we changed the decimal place by 3 spots. This one's moving backwards. This one's going backwards 3 spots. It's a small number, so we know we're going to have a negative exponent, and it jumps just behind that 4. This could be 4.0 or just 4. 4 times 10 to the negative third. It moved 3 spots backwards, and we're dealing with a small number. It's another way to confirm that it needs to be negative. This one we have to write out first. This is 57 million. That's going to have 6 zeros. Again, that's a big number. The decimal place starts out behind the number 1, 2, 3, 4, 5, 6, 7 spots up. It's going to be in between the 5 and the 7. That's a number between 1 and 10 times 10, and that moves 7 spots. It's times 10 to the 7. Again, you have some practice at the bottom. You're expected to complete that for homework. Please ask questions if you need it.